Before you embark on your learning journey, it's a good idea to learn how you can navigate through the course interface and make the best use of the available features. When you access a module, you'll first view the landing page, which displays its title and the content structure. You can begin the module by clicking the Start Module button. This takes you to the first lesson. You can also view the content structure for each module in the left panel. Each module is divided into sections, and each section consists of lessons. You can also navigate to any lesson by clicking the lesson title in the menu. Note that you can go through the lessons in any order, and you can revisit them at any point. Keep in mind that to complete a lesson, you must scroll all the way down until you see the button that indicates the title of the next lesson. You can check your progress of the module at 2 levels. If you're looking for a specific topic, you can use the search feature. Videos are played using a custom smart player, which provides several features. The Captions button enables you to switch off or display the captions in one of the available languages. You can also customize the way captions are displayed by clicking on the caption settings. From here, you can increase or decrease the font size of the captions and even choose between different colors and transparency levels for the caption's text and background. If you prefer a faster or slower playback speed, you can change it in player settings. To navigate to other modules in the course, you click the Previous or Next buttons. You can also click the View Full Path button to view all of the modules available in the course. To complete a course, you must complete all of the modules that are marked Required. You're now ready to expand your learning horizons at UiPath Academy. Happy learning! Hello! Welcome back to the UiPath Production Ready Essentials training. In this tutorial, we're going to learn more about the state machine, when it's best to use this layout, and how to set states, conditions, and transitions within it. We're going to automate a payments process in which input from the user and predefined conditions determine the transition between several states. As you will see, our process is a bit more complex, and we need a layout that allows us to easily define transitions between states, without using a lot of loops and if statements. Given all the requirements, the basis of our workflow will be a state machine layout. So, what will our workflow do? It will ask the users for their initial balance, then prompt them to add the value of the amount that they want to pay. Then, depending on several predefined conditions, either prompt them to make a new payment or display a message informing them that the process is finished. Let's get going. We start the project as a sequence, and then we add a state machine from the Activities panel. To get the initial balance from the user, we add our first state. By linking it to start, it becomes the initial state of the process. We'll rename it getInitialBalance and add an annotation to document what we're trying to do. Get initial balance of the account. We double-click to open it. We notice that a simple state has 3 editable sections. The entry section holds the activities that will be performed when the state is entered. The exit section holds the activities that will be performed when exiting the state. And the transitions section describes the current transitions this state has in relation to other states. So what we want to achieve in the initial state of our process is to ask for the initial balance from the user. For that, we'll use an input dialog activity in the entry area and prompt the user to insert a number. We'll then need to store the output of the activity in a string variable called input value. Make sure to set a global scope, in this case state machine, for all the variables that you use throughout this workflow. Now we need to make sure that the input provided by the user is valid. In our case, the input should be a double, a number holding maximum 16 digits. To perform this conversion, we use an if activity and the double.tryPass method, which returns a Boolean value, true if the conversion was successful, and a false value if the conversion failed. Then we'll create a new variable called currentBalance and set its type to double. If the input value variable can be passed with the before-mentioned method, it is in the currentBalance variable where we assign its value by using a double.pass method. If the input value cannot be passed, we will then notify the user that the input is not valid by using a message box activity in the else area. We also create a new Boolean variable for storing data about the fact that the user input is not valid. We'll call it isValidInput, and we'll set the default value to true. We'll then use an assign activity under the message box to assign the value false to isValidInput. From this point, the execution can take 2 different directions. If the input is not valid, the user should be prompted to close the payment process. This means that the process will transition to its final state, and therefore, the execution of the process will stop. We'll create the final state later on, but now let's see what is the second direction the execution can take. If the input is valid, the user will be prompted to input the value of their payment. This means that the process will transition to the getPaymentValue state. So, let's go back to the state machine view and create this next state. The easiest way is to copy and paste the getInitialBalance state, then rename it to getPaymentValue. We'll also add an annotation to document the purpose of this step. getPaymentValue for current iteration. Now let's double-click to open the state and rename the input dialog to paymentValue. At this point, the user will input the amount that they want to pay, so we need to store that input in a new variable called paymentValue. We'll set its type to double and give it a global scope. In the copied assign activity, we now need to replace the currentBalance variable with the newly created one, paymentValue. So, what we've just done helps us to cover both the scenarios in which the user adds a valid double value or an invalid one. Going back to the state machine view, we notice that our process does not have a final state yet. And when using a state machine, it is mandatory to have one. Let's go ahead and create it, then add it at the bottom of the workflow. We'll double-click to open the state. You can see that the structure of a final state is different from the one of a simple state. The only area available is the entry area, which holds the activities that are performed when the state is entered. As the name implies, this is the last state that the process can be in, and therefore we cannot define any transition from a final state to any other state. Now let's go back to our example. When the users get to this point, we want to notify them that the process is finished. We'll do so by using a message box activity in the entry area of our final state. So, we now have an initial state, a simple state, and a final state. It's time to add our first transitions. Up to this point, the user will input their initial balance, and next, they'll then be prompted to input their payment value. That can only be triggered if we create a transition between the getInitialBalance state and the getPaymentValue state. Now we do that by simply adding a line between the two. Then we double-click to open the transition and rename it to ValidInput. So, if we remember, the condition for the process to move from the initial state, getInitialBalance, to the payment-value state is to have a valid input from the user. So we set the condition that the transition should only be triggered if the isValidInput variable is true. For the scenario in which the input from the user is not valid during the initial state, getInitialBalance, we'll create a transition from the getInitialBalance state to the final state. And we'll set the condition that the transition should be triggered if the input is not valid. And we've now added all the transitions starting from the initial state, getInitialBalance. After exiting this state, the user will either be prompted to add their payment amount, or if their input is not valid, they'll be prompted to finish the process. But if the user transitions to the state of adding their payment amount, there are 3 possible transitions to the next states. If they add an invalid payment input, the process will stop, and we transition to the final state. We already have a transition in place for that. If they add a valid payment input, but they don't have enough balance to pay the amount, their payment will be denied. For that, we'll need to create a new state and a new transition. If they add a valid payment input and they have enough balance to pay the amount, their payment will be made. For that also, we'll need to create a new state and a new transition. In the case of payment denial, we want to let the user know that the transaction could not be performed due to insufficient funds. We'll also want to display their current balance and ask them if they want to continue with another transaction. So, how do we do that? We add a new state. Rename it Deny Payment and add an annotation stating what the purpose of the state is. Display message about payment denial. We then open the state and add a message box activity in the entry field to notify the user that the payment could not be processed due to insufficient funds. We continue typing an expression in the message box that returns the current balance to the user. And we finish up by asking the user if they want to continue. We then close the message box and set its option to yes/no to get input from the user regarding what they want to do next. And we'll store this input in a new string variable called continueAnswer. If the user has enough balance to pay the amount, we want a state in which we will subtract the payment value from the current balance. Then we'll let the user know that the transaction was processed, display the value of the current balance, and ask them if they want to continue. The easiest way is to duplicate the deny payment state. Rename it Make Payment and add an annotation stating what the purpose of the state is. Display message about payment and new balance. We then use a message box in the entry field to notify the user that the payment was processed successfully. We now need to subtract the payment value from the current balance. For that, we add an assign activity above the message box and rename it Reassign Current Balance. We then type the method for subtracting the payment value from the current balance. Now, we have states in place to cover all possible scenarios. Transitions. So, the payment input was valid. will be denied. Thus, the process will transition from get payment value state to deny payment state. Let's add this transition. Open it, then name it insufficient funds and make sure that we set the right condition. If the user's payment input was valid and they have enough balance to pay the amount, their payment will be made, and thus the process will transition from get payment value state to make payment state. Let's add this transition. Open it, then name it sufficient funds, and make sure that we set the right condition. Now let's make sure that we have set all transitions correctly from the get payment value state. Great, everything seems in place. Please note that it's recommended to define transitions in a way that only one transition at a time is true. As we did in our example, we set that by adding a condition in the deny payment and make payment states to only trigger the transitions if we have valid input from the user. However, you should know that if there are more transitions active at the same time, only the first one defined will be executed. So, let's go back to our process. Now we only need to make sure that we have all the transitions in place for deny payment and make payment states. Now there are two possible transitions from each. When prompted to continue, the user can respond with yes or no. Let's start with the scenario in which the user does not want to continue and selects no. We'll start with deny payment state. In this case, the workflow transitions from the deny payment state to the final state. Let's create the transition, rename it to stop, and set the condition. Then we'll continue with the make payment state. The workflow transitions from the make payment state to the final state. Let's create this transition, rename it to stop, and set the condition. Now, let's cover the scenario in which the user wants to continue and selects yes. We'll start with deny payment. If the user selects yes, then they'll be sent back to adding a payment value. So, in our workflow, a transition is triggered from deny payment state to get payment value state. Let's create the transition, rename it to continue, and set the condition. And we'll continue with make payment. If the user selects yes, the same happens. They'll be sent back to adding a payment value. So, in our workflow, a transition is triggered from make payment state to get payment value state. Let's create the transition, rename it to continue, and set the condition. And with that, all of our states and transitions are now defined. We check one last time if all the possible scenarios are covered. Yep, everything seems in place. We can now run our workflow. As you can see, we are prompted to add our current balance. The input provided is valid. How do we know that? Well, because otherwise we wouldn't be able to add the value of the payment. Then the payment amount was subtracted from the original balance and the new balance is displayed. We now have the option of continuing with the process. Once we select yes, we are asked to make a new payment. We add the value of the new payment and then the new balance is again displayed. Once we select no, the message box notifies us that the process is finished. And that was the final state of our process. And that concludes our lesson on state machines. Thank you for watching. Welcome back to the UiPath Production Ready Essentials training. In this tutorial, we're going to learn how to break down a process into smaller workflows that allows independent testing of components and encourages team collaboration by working on separate files. Nonetheless, we'll be using arguments to pass data from a project to another. While with variables, you can pass data between activities, with arguments, you can pass the data between automations, and thus, we can reuse automations. Let's start with process breakdown. There are multiple ways in which the workflows can be split. The first approach would be to split the process based on an individual platform. In other words, we can add all the activities related to an application in a single workflow. As a best practice, the sequences should not be very long or complex, so that they can be easy to understand, read, and test. However, for a complex process design, we recommend combining the platform splitting with the purpose of the workflow. To do so, after we split the process for each application into separate workflows, again, for each of those applications, we'll break the process as input, processing, or output. As an example, let's imagine that we need to log in and log out of an application multiple times throughout a process. Naturally, we'll build these activities as separate workflows that can be reused and invoked in each process. Workflows that can be reused should be identified from the initial stages of development so that they can be extracted as separate workflows to be invoked. They can also be extracted as libraries, based on the number of applications used and the times that each step is performed. Let's see how this works in our project. We have two states, get initial balance and get payment value. Navigate to the get payment value state and double-click to open it. Here, let's take a look at the if input is valid activity. The same type of activity is used in the get initial balance state if we go back to the main project workflow and access it. Now that we've identified that we have the same set of activities used twice in our process, let's try to build our first activity as a separate workflow. We'll first select the activity, then right-click to Extract as Workflow. Let's rename this activity to Input Validation, then hit Create. As you can see, our workflow has been created and has been added as a separate .xaml file to the project panel. Now, back to the Get Initial Balance activity, you can see our invoked workflow. To access the workflow again, click on Open Workflow. From this view, open the Arguments panel. Arguments have specific directions, such as in or out properties that tell the application where the information is stored and where it is supposed to go. Additionally, UiPath Studio supports many argument types, which coincide with the types of variables. And therefore, you can create generic value, string, boolean, object, array, or data table arguments. And you can also browse for .NET types, just as you do in the case of variables. Let's move on to naming our arguments. We recommend that argument names should be in upper camel case, with a prefix stating the argument direction, such as in_input value, out_passed value, and Joe_is valid input. We'll also need to set the argument direction to in or out, otherwise it will fail. Next, change the input condition. And we're done. Let's save our workflow and go back to the main project. We can see here the Invoke Input Validation workflow. Now, we need to import our arguments as we've changed their name as follows. First, we assign our input value. Secondly, we assign our output value as current balance. And lastly, we assign isValidInput a value. Let's press OK. Remember that we can also edit our arguments from the Properties panel. Now, let's invoke this activity in another workflow. We'll get back to the State Machine project canvas and navigate to the Get Payment Value state. We want to add the same activity called Input Validation into Get Payment Value state. Drag and drop the input validation.xaml file to the workflow and then select and delete the other activity as we'll no longer need it. Let's validate if the activity leads to the same location. And it does. Switch back to the main.xaml and select Import Arguments, just as we did previously. This is how you manage the arguments. Let's run the project. Add a numeric value to the current balance pop-up, and then add a payment value. And it works. This concludes our lesson on how to extract as workflow, invoke workflow, and arguments. Thank you for watching. Hello, and welcome to a new tutorial on project organization. In this video, we're going to talk about libraries. Before we begin, let's go through the basics of what a process library is. Libraries are packages that contain multiple reusable components, which consist of one or more workflows that act as individual activities. Libraries are saved as nupkeg, NuGet package files, and can be installed in different workflows using the package manager. In this demonstration, we'll create a new library process operating on the Acme website. Later on in the training, we'll use the library to automate a process. Let's start by opening Studio and selecting New Project Library, which is a new type of project available in UiPath. Once the library wizard appears, proceed with entering a name, Acme Library, a location, and a description for the new project. Note that these details can be changed at any time by editing the .json file. Alright, now we can hit the Create button. So, now that we have a blank library project, let's see how a user logs into Acme, downloads all the work items, and logs out. Open the Acme website, type in the username and the password, and hit the Login button. In the dashboard view, navigate to Work Items from the left-hand side menu. The search results will display a list of work items, and for each row in the table, a user will download and save it. Then go to the homepage and log out. Let's proceed with adding these actions into libraries. We'll rename our first activity Login. Now, let's create the login workflow, which will open the browser, navigate to Acme, enter our credentials, and log in. Now we'll add activities to our project. Let's fast forward through this part, as the workflow consists mostly of familiar UI interaction activities. And let's start adding activities to our project. First, add a sequence into the main panel, and then search for Open Browser Activity Type. Now, let's add the link URL between quotation marks. To add the email address, we'll use the Type Into activity, which will indicate on the screen. Now, click in the Input field and create an argument using Ctrl+M username. Next, we'll add Type Secure Text String, considering that we'll need to add the password, which needs to be secured. Again, we'll indicate on the screen the password field. And now, on the Properties panel, we'll create an input argument called password. And finally, we'll add a click activity to capture the login button. Note that according to our naming convention, arguments should be named using the Pascal case standard. The name of the arguments should not contain in_out_/io_ prefix, because those arguments will appear as properties when the library is being created. After all the sequences for logging into Acme website have been completed, let's move on to creating the next section, which is download all items.xaml file. Create a new folder by right-clicking on the project panel. Press Add and then Folder. Let's name it Work Items. Inside the newly created folder, we'll add a new sequence named Download All Work Items. Now, expand the Work Items folder to see the .xaml file. For the purpose of this demo, we're going to jump to the point when we've created all the sequences. Now that all the activities for the Acme library have been created, log in, log out, and download all Work Items.xaml files. You'll notice that we also have two grayed out actions, Navigate to Homepage and Navigate to Work Items. These are what we call private workflows. You can change the workflow type to private by right-clicking and choosing Make Private. To revert to the initial workflow type, choose Make Public. A private workflow will not appear as an individual activity when the library is installed in another workflow. However, it can be used inside the library. In this example, Download All Work Items, we are using Navigate to Work Items private activity, as users don't necessarily need to know how to navigate to a specific location, but only need the downloaded structured data. Now, let's publish our library. In order to publish a library, we'll hit the Publish button located on the main menu. And we can publish our libraries either on the orchestrator or on a custom folder. In this demo, we're going to choose the custom folder. Also, in this view, you have the option to modify the version of your published library. In our case, we're going to leave it as is. Now, in the library settings, if we choose to tick the Include Sources box, all the .xaml file sources are packaged within the library, including the private sources. This can be helpful in debug mode. Alright, let's publish the library. Now, the library has been successfully published and has the name of the library project that we chose earlier. Okay, we're done. So far, we've learned how to create a library project and what the publishing options are. Let's proceed with using the library in a different process. We'll create a blank process named Acme Test. In order to use our previously created library, all we have to do is go to Manage Packages and then choose the feed where the library has been published to install it. But first, let's create a new feed by going to Manage Packages, Settings, press the plus button, and enter the name and add the source location for this feed. Move on to the library feed to find the previously published library, and we can go on and install it now. Let's look at the project. The reference for this library was added in the Activities panel, where we can now see the generated activity. Expand the Acme library to see the name of each reusable component, as well as all the folders and subfolders which have the same position in the tree as configured when designing the library project. Log in, log out, and download all work items. Now, we should be able to invoke the reusable component by dragging and dropping from the Activities section, just as we would do with any other activity. If you do not have UiPath.credentials.activities installed, go to Manage Packages and install it. We'll add a Get Secure Credential activity, which is in the UiPath.credentials.activities package. Let's create a generic Windows credential called Acme Credential. To create a generic credential, go to your Windows Start button, access Credential Manager, and select Windows Credentials. Next, add a generic credential and enter Acme Credential in the Internet or Network Address field, and your Acme username and password in their respective fields. Next, we'll use these credentials in Studio. Set the target to the generic Windows credential, Acme Credential. And you remember, we would need to have two arguments, a username and a password. Now we should create two new variables, the first variable password and the second one username. Next, drag in the login activity under our Acme library and then add these variables as the login input values. Next, let's add the download all work items activity. And now we'll add a value for the extracted work items called extracted values. To extract the work items values into an Excel file, we'll use the Excel application scope and we'll name it test.xlsx. Additionally, we'll add a write range activity in which we'll add the table extracted values created previously. And finally, add the logout activity and run the workflow. One last thing, let's verify that the Excel file has been created. Here it is. As you can see, we have the test.xlsx file created, and it contains all the downloaded work items. That was it for this video. Thank you for watching.